We're given f of x equals 1 divided by the quantity 3x minus 2 raised to the third. We want to find f prime of x, the derivative function, and f prime of 1. The first thing we should recognize is that the given function is a composite function, which means we'll have to apply the chain rule to find the derivative. But we want to apply the extended power rule given here, which is the basic power rule with the chain rule built in. To do this, though, we'll have to change the form of the function, where if we have f of x equals 1 divided by the quantity 3x minus 2 raised to the third, to avoid using the quotient rule, we can move this up to the numerator, which would change the sign of the exponent. This would be equivalent to f of x equals the quantity 3x minus 2 raised to the power of negative 3. In this form, we can go ahead and apply the extended power rule given here, where again u is the inner function. So notice in this case u would be equal to 3x minus 2. So if we have u equal 3x minus 2, we also need u prime. U prime would just be 3. So now we can write the original function f of x as f of x equals u to the power of negative 3. And now to find f prime of x, we'll apply the extended power rule. We'd multiply by the exponent, that's going to be negative 3 times u to the, we need to be careful here, we're subtracting 1 from the exponent. Negative 3 minus 1 is negative 4, and then times u prime. Well, we have u and u prime right here, which means f prime of x is equal to negative 3 times the quantity 3x minus 2 raised to the power of negative 4 times 3. So f prime of x is equal to, this would be negative 9 times the quantity 3x minus 2 to the power of negative 4. So this may be fine as our derivative function. Let's also show how we can write this using a positive exponent. We can move the base of 3x minus 2 down to the denominator again, which will change the sign of the exponent. So we could also say f prime of x equals, the negative 9 is going to stay in the numerator, divided by the quantity 3x minus 2 raised to the positive fourth power. And now for the second part of the question, we want to find f prime of 1, which would give us a slope of the tangent line at x equals 1, or also the instantaneous rate of change of the function at x equals 1. So f prime of 1, let's go ahead and use the function in fraction form, would be negative 9 divided by the quantity 3 times 1 minus 2 raised to the fourth, which would be negative 9 divided by, well, 3 minus 2 is 1. We have 1 to the fourth, which of course is just 1. It's equal to negative 9. So f prime of 1 is equal to negative 9. Let's go ahead and verify this graphically by looking at the slope of the tangent line at x equals 1. Here's a graph of our function. Notice when x equals 1, the point on the function, or point of tangency, is this point here, the point 1, 1. To find this y-coordinate, we'd have to substitute 1 for x into the original function given here. And because f prime of 1 was equal to negative 9, the slope of this red tangent line is negative 9. I hope you found this helpful.